All right, here's day 3. When you're ready to scroll down for number 4, do so. When you're ready to go to the next slide, go ahead and do so. Okay, number 1 on the warm-up. All week, we're given some information. In this problem, we're given the area and we're given the width. We plug it into the formula. The only difference today, the only thing that's a little trickier is in this case, the area was actually a mixed number. So we had to convert that to an improper fraction before we can solve. So it's a one-step equation. 3 over 2 equals length times 1/4. The inverse of times 1/4 is divided by 1/4. So the math problem that you have to do to get the answer is right here. It's 3/2 divided by 1/4, which gives you 12 over 2, or 6. The second one, order of operations, we're still writing parentheses, exponents, multiplication, division, left to right, addition, subtraction, left to right, off to the side. In this problem, there are no parentheses, there are no exponents. We do have multiplication and division. In this case, the division comes first in the problem, so the first actual math we're doing is 6 divided by 2. We get that answer and drop everything else down. So 3 times 4 minus 5 plus 7. Now we have multiplication, we do that. 12 minus 5 plus 7. A common mistake here is people will get 0 because they'll add 5 plus 7 first. Addition and subtraction are from left to right. In this specific problem, the subtraction is first. 12 minus 5 is 7. 7 plus 7 is 14. Number 3, you got to do a little bit more work than yesterday. The length of a rectangle is 6 units longer than its width, W. Which choice is a correct expression for the perimeter of the rectangle? Well, you had to be a little bit of a detective in the problem and see that it tells us 6 units longer than the width, W. So the width is W. So I labeled my width as W. And it says the length is 6 units longer. So it's whatever the width is plus 6. Whatever the width is plus 6. Combine our like terms, and we have our answer. Number 4. We've been showing the really kind of slow basic method to solving this where you drew the whole number line out and counted each tick. The more comfortable you get with this, the easier it becomes. Really what we're trying to do is see how far apart -5 and +4 are. So from -5 to 0 is a total of 5 units. From 0 to 4 is a total of 4 units. So altogether, they are 9 units apart. Okay, today, the inequalities daily dose is 4 graphs. Pause the tape and graph them. Okay, number 1. Okay, all of these numbers are less than -7. They're all less than -7. I'm going to do the bottom left one next because it also shows less than. But the difference between these two graphs is this circle is colored in, which means 4 is included in the solution set. So while this is x is less than -7, this is x is less or equal to 4. Top right, these numbers are all greater than -2. But the thing is, because the circle is colored in, these numbers are greater than or equal to -2. These numbers are greater than 1. Okay, so today we're going to start looking at box plots or box and whisker plots. And here's an example of a box and whisker plot. Most of today is really just going to be about talking and taking some notes and just kind of thinking. So when I look at this, it shows scores for the 6th grade math test. So the first thing I notice is in a box plot, like all this empty space in here means that right there was the lowest score. So nobody scored in this range and nobody scored in this range. So nobody got 100 and nobody got less than a 65. Those are the first couple things that I notice about this graph. Now we're going to look at some features of this graph on the next page. You're going to take some notes. But the box itself is an important part of this graph, which makes sense because it's called a box and whisker plot. So the box of this graph is right here, and this box has some specific features to it. The most important being that line right down the middle is the median score. So the median score on this 6th grade test was an 85. On this slide, there's quite a few pieces of notes. There are 5 pieces to the box and whisker plot. The end is 1 piece. The beginning of the box is 2, the median is 3, the end of the box is 4, and the edge or upper extreme is 5. So there are 5 parts to this box. Go ahead and take these 5 parts into your notes now. Okay, so when I go back to the graph on the previous page, the minimum or lower extreme represents the smallest number in this data set. And in this graph, the minimum is located right here. It is on the very end. On the opposite side, the maximum or upper extreme is the greatest number in a data set. So we can't tell exactly, but from looking at this graph, it looks like the maximum, the highest score on this test was around a 97, and it looks like the lowest score on this test was around a 68. So this end, the whisker over here, represents the minimum. This end, the whisker, represents the maximum. We also have the median, which is the exact middle number of any data set. And the median on a box and whisker plot is always described by this line that goes right down the middle of the box. It could be anywhere in the box, but the line, the vertical line in the box is the median. And then we have what's called quartile 1. And quartile 1 is really the beginning of the box. So this line right here that I just redrew in black represents quartile 1, and this line right here, the edge of this box, represents quartile 3. So there are, quartile 3 is right here, that right there is quartile 3. So there are 5 pieces to a box and whisker plot. The minimum or lower extreme is the smallest number in a data set. The maximum or upper extreme is the largest number in the data set. Those form the whiskers. The median is the box down the middle. The quartile 1, which we'll talk about over the next couple days, is the beginning of the box. Quartile 3 is the end of the box. So here's a little label activity. Using those 5 terms in your notebook, go ahead and label each term. Okay, as we're doing this, the easiest thing to do is start with the whiskers. So down here is the minimum or lower extreme. It's the lowest number in the data set. Over here is the maximum. The smallest and largest numbers are pretty obvious. They're the edges of it. There's the line down the middle. That represents the median. That's the middle of the entire data set. The beginning of the box is quartile 1. The edge of the box is quartile 3. If you could not match those up, go back and take a look at your notes before we move forward. Okay, box plots. The interesting thing about a box plot is all of the data is split evenly among the 4 parts. So 25% of the data is here, 25% of the data is here, 25% of the data is here, and 25% of the data is here. Now you'll notice that the size of each piece aren't all the same, and that's okay. What it's saying is if we had numbers on this graph, so I'll make it a little bit easier to understand. As we have these numbers on the graph, we can't tell by looking at the box and whisker plot how many total people answered this. All we know is that 25% of the people answered with a number between 2 and 4. 25% of the people answer with a number between 5 and 8. 25% of the people answer with a number between 8 and 12. And 25% of the people said a number between 12 and 13. So even though the actual pieces of the box are different sizes, every part, this contains 25% of the data. Each part of this contains 25% of the data. So there's another 25% of the data here, another 25% of the data here, and another 25% of the data here. So when we start thinking about this, if we were asked what percent of the data is less than 8, well, this piece is less than 8. So let me use a different color. This piece is less than 8. And this piece is less than 8. So there is 50% of the data that is less than 8 because each of those pieces represents 25%. If we had to know what percent of the data is more than 4, this is more than 4, this is more than 4, and this is more than 4. 3 pieces or 75% of the data. Okay, so here is a box and whisker plot with some basic information on it. Pause it and just copy the basics into your notes, and then answer these discussion questions. Okay, what percent of the data is greater than 19? Well, I'm going to my graph. Here's 19 right here. The median is 19. One piece, two pieces. Two pieces with each piece representing 25% means that 50% of the data is greater than 19. What is the value for quartile 3? Well, that's a simple one because lowest number, highest number, median, Q1, Q3. Q3 is 21. Q1 is 15. And the last question, what percent of the data is less than 21? 25, 50, 75% of the data is less than 21. Okay, here's a similar box and whisker plot. If you're ready to go to your work, you can go ahead and go to your work. If you need one more example, we'll look at one more example together. It says, what percent of the scores were greater than 72? Here's 72. 72 represents Q1. 25%, 25%, 25%. So 75% of the scores were greater than 72. Question 2 says, what percent were less than 88? Find 88 on the graph. 25, 50% were less than 88. What percent of the scores were between 96 and 72? Ooh, I like that. Between 96 and 72. So here's 96, here's 72. So really it's asking us the whole box. And each part of the box is 25%, so that is also 50%. And the last one, what is the difference between the highest and lowest scores? Well, the highest score looks like somebody got bonus points, got 102. The lowest score is 38. So to find the difference between them, we're just going to subtract. All right, the work for today is bit.ly/box day 1.